Hey guys, sorry that I have to teach you this via video, but it is pretty much review. So even though it's going to be a little bit long, it shouldn't be that hard to follow. And you know you're always welcome to come in if you have questions, and we'll go over stuff next week on Tuesday as well. The kicker is I already made this video one time, and for some reason, my laptop messed it up or whatever messed it up, and it doesn't work. Toph, I wish you were here to help me. So anyway, I'm going to do it again. I hope I do it as well. And I hope I don't sound as exhausted as I actually am. So what we're going to start with is right triangle trig, which you did learn last year. SOHCAHTOA is the memory tool we use for right triangle trig. So remember, it has to be on a right triangle. We call it right triangle trig. Here's a right triangle here. I've named it A, B, C, and A, B, and C are the vertices. So those are the corners or the angles of the triangle. Okay. Now remember that SOHCAHTOA is used to help you memorize what each of the trig functions um, ratio is, but you still have to remember what the letters stand for. Okay. So let's go over to this triangle real quick and get it set up so that we can use it. Notice it only has the angles labeled A, B, and C because that's all we ever name on a triangle. But we're going to need to use the sides. So when we want to use the sides, then we will name them based on the angle opposite them. So angle A is up here. This is side. Opposite it, we'll call it lowercase a. Okay, and then we'll do the same opposite of angle B is lowercase b. That's a cursive B, which I use because my printed B's tend to look like sixes. And then C will be over here. Okay, so that's a lowercase. All right, so remember, S in so is for sign. Um, it is spelled this way. The abbreviation is like SIN, but please don't call it sin. It's still sign. And remember that the memory tool OH is to remind you that it's going to be the opposite over the hypotenuse. Okay, and then cosine is A over H, so it's going to be the adjacent over the hypotenuse. And tangent is O over A, so it's going to be the opposite over adjacent. So hopefully you remember those. You just may not remember it before. So when I ask you to find a trig ratio, I have to give you an angle that I'm referring to because they will be different for different angles. Now, remember, I did say this the other day. Hopefully, you remember it from last year as well. That you can only find these sine, cosine, and tangent of the acute angles, not the right angle. That's why this trig is very limited because you can only find it for angles less than 90 degrees. Well, on the circle, we can have as big an angle as we want. We had bigger than 360 degrees, and that will be just fine. But for a triangle, it can only be for these two angles that are acute. It does not work for the right angle. So that'll be interesting when we get to the circle trick. All right, so how do we know which angle they want us to use? Well, they write it here, put it in parentheses. After sign, they put in the parentheses B, so they want us to use B. So if we're going to use B, we have to know what the opposite, adjacent, and hypotenuse are in this triangle. So hypotenuse, guys, that never changes, right? Okay, it's always opposite the right angle. So I always mark that one first. Back when I was first learning this, I would mark the hypotenuse before I figured out the other two sides because it doesn't change. Then the side opposite angle B, and it's because that they want us to find sine, cosine, or tangent of angle B. The side opposite we're going to call the O, or the opposite. And then the other side, all it's left is adjacent. So I always tell my students when I learn this, do a hypotenuse first, then the opposite side, and then your last one has to be the adjacent. So if we go up here now and we want to make fractions or ratios, ratio is just a fraction, with these sides, then the opposite is side B and the hypotenuse is side C. And so that means the sine of angle B is B over C. So for cosine, the adjacent is A, hypotenuse is C. So cosine is A over C. And for tangent, the opposite is B, and the hypotenuse is C, so it's B over C. All right, so those should not be new. If you don't remember them real well, there's got to be at least 100 videos online. And again, you can come see me, or I won't reteach that in class, but if you have just a quick question, of course, you can ask that. All right, so there's some new ones that you haven't learned. We're going to use these not so much in this lesson today, but we'll use them a little bit in the future, and then you'll use them even more in pre-calc. Those are cosecant, secant, and cotangent. And I always tell my kids to pay close attention to the fact that the S in sine and the C in cosecant go together, and then the C and cosine and the S and secant to go together. So the S and C's go together. Don't think the S's go together and the C's go together, because that's not going to be the case. And then tangent and cotangent, I think that was pretty obvious that they go together. So cosecant, the reason I say it goes with sine is it's the reciprocal of sine. Okay, so what's a reciprocal look like? It's 1 over. So it's 1 over sine. And secant is the reciprocal of cosine. So it's 1 over cosine. And cotangent is the reciprocal of tangent. So it's 1 over tangent. Now remember, taking a reciprocal is easy for a fraction. You just flip it. So if sine is b over c, so here it's b over c, then the cosecant will be c over b. It will be just the reciprocal. And then for cosine, if it's a over c, then the secant will be c over a. And then the cotangent is the reciprocal of tangent, so it's c over b. All right, so then let's see if we can apply that to this triangle here. And we've got the triangle set up. We just need to write the fractions. So they want us to use angle A. Sound might have changed. If it did, sorry, I hope it's better, not worse. I just put in my earbuds because I realized that my microphone and my laptop doesn't always work. All right, so they want us to use angle A. So the first thing, remember I said, find your hypotenuse, that's over here. Find your side opposite, that's here. And then what's left over will be there, that is A. So sine will be the O over H, which is 12 over 37. The cosine will be A over H, which is 35 over 37. And the tangent will be O over H, which is 12 over 35. Okay, so we're just writing the ratios right now. Cosecant then is the reciprocal of sine, so that's 37 over 12. The secant is the reciprocal of cosine, so it's 37 over 35. And cotangent is reciprocal of tangent, so it's 35 over 12. All right, so I'm going to pause. I recommend you do the second one, and then I'm going to give the answers. So what I'm saying is I suggest you pause this video, go to the notes, fill them in, make sure you understand it, and then restart the video, or, pick up on the video again. Okay. So sine is 16 over 34. Cosine is 30 over 34. Tangent is 16 over 30. Cosecant is 34 over 16. Secant is 34 over 30. And cotangent is 30 over 16. Hopefully you got those right. Hopefully you tried them. All right, so how do we use these? Well, we can use them either to find a missing side or to find a missing angle. And to find the missing side, what we do is we take the angle they gave us the measure of, and that's the one we're going to use. And then what we have to do is figure out which two sides in relation to that angle they gave us a measure for. So see, they gave us x, You might think that's not a measure, but it is, because we're going to figure out what x equals. And then they gave us 16. So 16 is the hypotenuse and x is the opposite. So that would be so. So that means we're going to use sine. So sine of 60 degrees, and then O is x over 16 in the denominator. All right, now to do this, you're going to need to have your calculator, and you can use a graphing calculator or you can use any calculator. It really doesn't matter. It doesn't take much fancy calculator to do this, but you have to make sure it is in degrees. So on your graphing calculator, what I have clicked on is mode, and see all of these different options I have. Well, there's radians, and I'm going to tell you, most of yours are probably in radians. So you need to toggle over. So just arrow over to degree and click enter. Okay, so let's see if I can get over there. If I toggle back and forth, nope, don't want to let me. Okay, so we got to go down to it. That's why. Okay, so whatever one is flashing when I hit enter is the one I'm going to be choosing. So I enter here, and that means it's degree. All right, so now I can do my trig on my calculator. All right, so let's look to see what I need to do. But it has to be in degrees, guys. If it's not in degrees, you're going to get them all wrong, and it's going to be very frustrating too. Okay, so I need to find sine of 60 degrees. I don't know what sine of 60 degrees is, although honestly I do, but you won't. So what I need to do to get out of this screen, you can always second mode, and that's quitting. Also, most of the time, if you just click the sine button, it'll pop up to you. So I need sine, I need 60 degrees, and I hit enter, and it's 0.8860. Okay, so I put that here now because that's what sine of 60 degrees is. And it's x over 16. And then I need to multiply that by 16. So times 16, 13.9. It says round to the nearest tenth, guys. You're not always, some of you aren't always rounding to the indicated unit. So make sure you are, okay? So, and it's not really equals, it's approximately. Okay, so the next one, they gave us this angle at 30 degrees. Let me figure out which sides they've given me measures for in relation. There's a 13, there's an x. Okay, so the hypotenuse is over here, but there's no measure for it, so I'm not going to be using that one. X is the opposite side, and 13 is the adjacent. So it's O and A, which is tangent. Okay, TOA. So I'm going to take tangent of 30 degrees. That'll be x over 13. All right, so go to my calculator, put in tangent of 30. Oops, let's try to use tangent first. Tangent of 30, 0.5774. Use 4 decimal places, guys, so that you get a good approximation, because it's still going to be an approximation. But and then I'll just hit times. I'm not going to re-enter that and make it a little more away, farther from accurate. If I just hit times, that works, and it's about 7.5. So x is about 7.5. Sidebar real quick. Sometimes you have a problem that looks like this instead. 10 at 30 degrees equals 13 over x. If that's what it had been, then after I had gotten to this step, I would multiply both sides by x. And then divide both sides by that decimal, and that would be how I do that one. Okay, so there'll be some on the homework, I think. If not, we need to make sure we practice some where your variable is in the denominator. All right, 5 and 6. Yeah, cut out 3 and 4. For these, we need to find the indicated angle. So that's working backwards, right? Because all the other ones, it gave us the angle, and we found a side. Now we're working backwards. Working backwards, working backwards. What should that make us think? That should make us think inverses. All right. So we're going to need to use the inverse here because we need the calculator to do this problem backwards. We don't want the calculator to take the angle and tell us what sine of it is. We want the calculator to take the answer the fraction and tell us what the angle is. Okay, so here is the angle I'm trying to find the measure of. This is H and this is A. So that is cosine. So if I'm taking an inverse, remember what that looks like, guys? That's a -1 there, like an exponent, but not technically. And so I need to find the inverse of x, and it will be equal to 36 over 43. These actually, once you remember that you have to use the inverse, are easier to do because it's a one-step problem. So on the calculator, if you use second, which is that blue button, and then the actual cosine button, look, there's the inverse. And I'll put 36 divided by 43 and enter. And it's about 33. Notice for degrees, we don't want any decimals. We just want whole numbers. So it's about 33 degrees. Okay, we go over to this one. We need this angle. This is the hypotenuse. This is the adjacent. Nope, sorry, that's the opposite. Like I said, I am getting tired. So OH is sine. So this is sine inverse of x equals 25 over 26. So if I go to my calculator, inverse of sine 25 divided by 26 is 74 degrees. Okay, so x is about 74 degrees. All right, so that should be all review. Let's see what how this can get a little more interesting. Now that you know a little bit more about some other trig functions. Okay, so we're going to use Pythagorean theorem, and we're going to find all the function values of theta. That's theta. Remember, it looks like this when we write it by hand. And what they've done is they've given us the sine. They told us the sine was 12 over 13. Okay, and they want us to find all 6 of these. Well, look at there. One of them is sine, which they already told us was 12 over 13. So guys, don't get all 6 wrong. If you can't figure out how to do all of them, you can at least get one of them, whichever one they gave you. All right, so this is supposed to be a right triangle, but I had trouble putting in the box. So if you'll put in the box, make it a right triangle. What you do is you're going to choose an acute angle. Oops, don't mess up with me, please. Choose one of the acute angles. Okay, it doesn't matter. Either one. To be theta. Okay, so you get to pick. As long as you don't pick the right angle, it doesn't matter. So I'll put it up here. Doesn't matter if I put it in the other spot down at the right. And I know that sine is 12 over 13. So that means the opposite is 12, okay, because this is my O. And the hypotenuse is 13, because that's my H. So all I need to do is figure out this side here, which is my adjacent, and I will be able to plug in all of the other things. Although, guys, I hope some of you are thinking, if you got sine, you also got cosine, right? Reciprocal. So truthfully, you should be able to get 2 of them right. The one they gave you and the reciprocal. All right, so how am I going to find that missing side? This one over here, what do I have to do? Well, they told us we're going to use Pythagorean theorem. So that, let's call it something though. Let's call it x. We'll call that side x. It doesn't matter. You could call it a since it's the adjacent, just a variable. So that leg plus this leg, that's 12. So x squared plus 12 squared equals the hypotenuse squared, which is 13. And you know what? If you know this Pythagorean triple, you're going to be lucky. It's going to be helpful. If not, if you set this all up, you should get x equals 5. So I don't know why I said it that way, but 5 is the measure of the adjacent. All right, so now we got all the parts we need. Cosine is a over h, so that's 5 over 13. Tangent is O over A, so that's 12 over 13. And then these here are the reciprocals, and we're done. Okay, so guys, the main steps here are to remember that you choose an acute angle, either one, to be theta, and you use Pythagorean theorem to find the missing side because the given information gives you 2 of the 3, and you have it. All right, so the last thing is the special right triangles. And special right triangles I always like to give this little demonstration, and it may help you, it may not, but I do think some of you will find it helpful. If you start with the square and you say that each of its sides measure 1, because we can pick whatever we want as long as they're equal, and we draw a diagonal. Okay, so now look what we have here. Now here we have this little right triangle. So I can use Pythagorean theorem to find the measure of the diagonal because it's the hypotenuse of that pink triangle. So I'm going to use Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. And that means that x is the square root of 2. So we can put that in here, square root of 2. And if I describe this triangle by its angles, that just means tell me what each of them measures. Well, we know that it's got a 90. And then remember that the diagonal bisects those other angles, so they're going to be 45. They were 90 when they were in the square. They're 45 in the triangle. So it's a 45, 45, 90 triangle. All right, then we have this triangle over here. This one is equilateral. And when it's equilateral, remember, all of these angles are 60. Okay? So now what we're going to do is we're going to, I just took all that stuff out because it's messy. We're going to drop a perpendicular bisector. Okay? What I forgot to mention is that we're going to say this side is 2, this side is 2, and this side is 2. Doesn't matter as long as we pick the same number for them. And when we do, this pink line that I drew going down will make this side 1 and this side 1. So now we've got this triangle here. We'll use this one. It's a right triangle. We've got a leg and a hypotenuse. What we need is the other leg. So one leg is 1, one leg is the x, and the hypotenuse is 2. So we get x squared equals 3, x is the square root of 3. So over here, that's the square root of 3. This triangle is a 90. We got this 60 here, so the other one has to be a 30. So it's a 30, 60, 90. All right, so even if that doesn't make sense to you, you do need to know this here, these shortcuts. Okay, on the 45, 45, 90 triangle, which we did first, if one leg is x, the other leg will be x. They will be congruent. And you'll take x and multiply it by the square root of 2 to get the hypotenuse. This 30, 60, 90, this one was like the one measure 1 up top, and this was twice that, and this was times the square root of 3. Okay, so you're going to have to know these however you need to learn them. You'll need to be able to do those to answer problems. Okay, all right, so what I'm going to do is I have all the different types of problems you could do. I'll do a demo. I'll pause just for a second. If you want to pause the video and go try them and then come back to the video, you can check them. That's my recommendation. Otherwise, if you just keep watching through, I hope you pick up all the little things. All right, so starting with the 45, 45, 90. When you're given a leg, it's pretty straightforward because the other leg will be the same measure. If this one's 4, this one is 4. And then you multiply the hypotenuse by the square root of 2. Okay, so 4 square root of 2. There isn't really much interesting, so I'm going to pause for a second. You can either stick with me or pause this video, go do them, and come back. Okay, so you've either done them and you come back, or you're just sticking with me. So if this one's a 2, this one's a 2. This will be times the square root of 2. Number 3, if this one's a 7, this one's a 7, and this will be times the square root of 2. 4, if this is square root of 2, this is square root of 2, and the one thing you have to recognize is that when you multiply by the square root of 2, you get just 2. All right, what if you're given the hypotenuse? Most of these are straightforward, but they can make them a little bit tricky, so I'm going to show you one of each, the straightforward ones and the trickier ones. So number 1 is very straightforward. If I'm going this direction, okay, so remember up top, I was multiplying by the square root of 2 to get the hypotenuse. So this direction, I have to divide by the square root of 2. So I'm going to take 9 square root of 2, divide by the square root of 2. It's going to be a lot easier if you make it as a fraction to divide. And so that means this is just 9. Now, most of you are probably like, yeah, I kind of get that. I'm sure you do, but that's going to be helpful when we get to number 3 because this is where they can make it trickier. To go to this one, again, I have to divide by the square root of 2. 7 divided by the square root of 2, you got to rationalize. So that means this leg is 7 square root of 2 over 2, and this leg is 7 square root of 2 over 2. All right, I'm going to pause for a second. I suggest you do 2 and 4 and then come back. Otherwise, just keep moving with me. Okay, so either you've done them and you're ready to check them, or you are just going to watch me. This one will be 3 and this one will be 3. This one will be 9 square root of 2 over 2 and 9 square root of 2 over 2. Please don't call that 4.5 square root of 2. Just leave it a fraction. Alrighty, now the 30s, 60s, 90s. There's 3 different things I can give you for these. I can give you the short leg, the long leg, or the hypotenuse. I will tell you that I think of the short leg as the base. And I think of it as like base when you're playing tag, where you always go back to base before you go back out. Because this one, everything is relies upon knowing the measure of the short leg. All right. Also, how do you know which one's the short leg? Sometimes it's obvious. These triangles are pretty well drawn. But if not, the short leg is opposite the smallest angle. That'd be nice just to kind of have in your head. Okay, so this is the short leg. It's 7. Since it's the base, I'm going to be able to figure out the other sides right from it. I will multiply by 2 to get this one, and I'll multiply by the square root of 3 to get this one. Okay, so number 3, maybe. Let's look at 3 because it's a little bit different. When I multiply by 2, please recognize that you multiply the 2's together. So that's 4 square root of 3. And when I multiply by the square root of 3, I multiply just the radicals together. So that's 2 square root of 9, which is 2 times 3, which is 6. So that's that one. Okay, so I'm going to pause. I suggest you do 2 and 4 and then start the video again. Okay, so either you've done them or you're just waiting for me. Either way, this will be 12. This will be 6 square root of 3. This will be 6. This will be 3 square root of 3. All right, next thing they could do is they could give you the long leg. They give you the long leg, you need to go back to base. Okay, base is the shorter leg. So go back to it before you try to find the hypotenuse. So this one, it could make it a little interesting. So I'll do 1 and 4. Which are the ones that are a little bit trickier, and then you should try 2 and 3 on your own. So to go this direction, I have to divide by the square root of 3, right? Because if I had gone the other direction, I would have multiplied. So this will be just 8, and this will be 16. On this one, number 4, as I said, that one's a little trickier. So I'm going to divide by the square root of 3, but that means I have to rationalize. And so that's the measure of y. And then I multiply that by 2. Now, guys, this is where sometimes kids make silly mistakes. When you multiply by 2, you only multiply the numerator because it's 2 over 1. So you don't multiply both, just the numerator. 10 square root of 3 over 3. And that's this one. All right, I'm going to pause. I suggest you do 2 and 3 and then come back to me. Okay, so number 2, when you divide by the square root of 3, you get 1, and you double that, you get 2. And on 3, when you divide by the square root of 3, you get 5, and when you double that, you get 10. So see, you always want to go back to the shorter leg. All right, last thing, what if they give you the hypotenuse? It's not bad because you just go back to home base, and that's just a matter of dividing by 2. Okay, so here is my hypotenuse, it's 4. If I divide by 2, I get 2, and then I multiply by the square root of 3. Let's put something, let's put a square root of 3 here. Okay, put a square root of 3 there, and then I recommend you do 2, 3, and 4, and then join me again. Okay, so hopefully you paused it and did those. If not, just watch me. Okay, so I'm going to go to the short leg first, that's 1. Then the longer leg, so that's 1 square root of 3. You don't have to write the 1, guys, but If you do, it's okay. Number 3, you're going to go this way first, so that's 7, and then this way 7 square root of 3. And number 4, hopefully you heard what I said to change that to 10 square root of 3, so that when we divide this by 2, you see that it's 5 square root of 3. And then when you multiply that by the square root of 3, you recognize that it's 5 times square root of 9, which is 5 times 3, which is 15. Okay, so you do have homework. It practices pretty much everything. This page should load. There. Okay, should practice everything, and we will go over it next week. All right, take care, guys.